Okay, so Assalamualaikum, good morning, and today we're going to continue our group presentation session, and today is also our last class, okay, final class this semester, and after the presentation, basically we are done in terms of the assessment, except for the test two that we're going to conduct next week Friday during the 2 week session as well. So 10 to 12 open book, which will cover from etching until the end of the course. Okay, so after this, basically you're done with the course, and I hope you have learned a lot from the previous sessions, from the previous lectures, and also you will learn a lot during these presentation sessions because you may not realize just yet as you do the presentation, you probably just want to get it over with. But later on, trust me, when you want to go for your internship interview or for your job interview, the content from this presentation session will be very, very useful. Okay. So if you notice, if you look at the titles of the group presentations, the titles revolve around fabrication of fat transistors, GaN LEDs, PERC silicon solar cell, SSDs, cadmium telluride, and one section in your presentation covers manufacturers. Okay, so you can instantly relate to which potential employers and manufacturers that are related or that are in the field. So bila you nak form, the you nak get the materials together for your preparation. Material tu dah ada kat sini. It's not like you have to get things from here, put together, prepare for your interview. You just open the right slides, you get pretty much the whole thing. It's just that you have to dive in and narrow down and zoom into more details. But you've got the skeletons ready pretty much, right? So for today's session, we're gonna have group number 3, number 4, and number 5. So group number 3 will be the first one. We'll be presenting on PERC silicon solar cell, and then we'll follow by group number 4, who will be presenting on solid state drive. And then finally, last but not least, group number 5 will be presenting on cadmium telluride solar cells. Right? So you've got enough members, right? Group 3, everyone's here. Yeah? Semua ada?
Yes.
Okay then, so over to you. Presentation will be for up to 20 minutes, and then we're going to have a Q&A session just like the previous session, right? Right then, bye. All the best.
Thank you to Dr. Zamir and very good morning, everyone. So our group representing about the fabrication of PERC silicon solar cell. And I'm Nur Sakina. Gonna start first with the introduction to PERC silicon solar cells. So before I go deeper into what is PERC solar cells, how is it different from normal solar cells, I guess it better if I could explain to you guys why we need PERC solar cells at the first place. So as we all know, the simple or typical solar cell has been invented in 1839 by Edmund Becquerel. And of course, there must be a lot of problems arises from these first invented solar cells. And these problems can make us questioning why these typical solar cells is not good enough. So as you all can see, this plain silicon, these plain silicon solar cells encounter few efficiency losses. So based on the above part of this diagram, these efficiencies with capturing sunlight, as the sunlight can be reflected to the solar cell itself, blocked by wires, or sometimes go all the way through the cell and turn into a heat. Thus, it reduces the cell efficiencies. Meanwhile, at the bottom part of this diagram, we can see that some electrons may recombine with the silicon material on the front and at the rear of the solar cell, or sometimes miss going through the circuit. So it must make us wonder how to overcome these problems to improve the efficiency of these silicon solar cells. So studies shown that the use of passivated emitter and passivated rear contact can overcome those problems, and thus PERC silicon solar cells were named. The P referred to passivated, E is emitter, R is rear, and C is contacts, or also can be called cells. These PERC solar panels were built with PERC cell, which have an additional layer on the back of the typical solar cell. And these additional layers allows more sunlight to be captured and turned into electricity, making these PERC cells more efficient than the typical cells. And these PERC modules are also able to mitigate the rear recombination and prevent longer wavelengths from becoming heat that would impair the cell's performance. And details of this PERC solar cell fabrication, how the process, what the material used, and etc. will be discussed by Faris and Haziq. And this PERC solar cells has been introduced by Martin Green and his team from the NSW, and they developed this PERC technology in the 1980s. So as you all can see, the fight for market share of PERC panels is very strong, with this 10% increment every year, making the PERC solar cell or PERC solar panels were in high demand throughout the year, and with various application of this PERC solar cell. Later will be discussed by Fakri Hadi. And this share market involved a few companies processing and manufacturing the PERC solar panel that will be presented by Shafiqah. And up to you, Shafiqah.
Can you guys hear me?
Yes, yes.
Hey, greetings. My name is Nur Shafika, and I'm going to present about the manufacturers related to PERC silicon solar cell. Okay, next slide. Okay, as one of the top 5 solar panel manufacturers in the world, Canadian Solar has a long history of success and big plans for the future. Okay, as the name suggests, this company headquarters is located in Ontario, Canada. Canadian Solar was founded in 2001 by Dr. Sean, making it a quite old solar manufacturer. It has since grown to employ thousands of people on several continents. The Canadian Solar offers a large number of products, including PERC solar cell, which is named Haiku. There are 3 varieties of the Haiku product line, which are the Haiku Poly, Haiku Mono, and All Black Haiku. Canadian Solar Haiku lines offer both product and performance guarantees. Canadian Solar's panels range is in efficiency from 15.88% to 20.6%. Okay, next, Seraphim is a young solar panel manufacturer founded in 2011 at Changzhou, China. Okay, Seraphim currently offers 3 lines of solar panels, the S2 series, which is ideal for home solar installations. Meanwhile, the S3 series and S4 series are meant for larger commercial and industrial installations. Okay, all of the current Seraphim modules use high-efficiency half-cut PERC solar cells. Rather than the typical square solar cell, Seraphim cuts its cells in half, which reduces the chance for cells to overheat and in turn improves cell performance. Finally, the company wires the panels into top and bottom halves, which means each half can output its full power even if either half is fully covered in the shade. Okay, compared to other brands on the market, Seraphim offers high-quality materials and industry-standard technology and performance. Its modules have efficiency of between 18.8% to 20.6%. Okay, next slide. Okay, JA Solar is a leading manufacturer of high-efficiency PV solar panels, founded in 2005 and based in Beijing, China, with several global offices, including one in San Jose, California. Okay, they produce high-performance solar panels for residential, commercial, and utility-scale projects. All of the JA residential solar panels utilize PERC technology. JA offers half-cut cell and PERC solar panels. The half-cut solar cell make solar panels more efficient, The cells are essentially split in half so that if one half is shaded or experiences malfunctions, the other half of the panel can continue to generate energy. Okay, an efficiency rating of above 20% is generally considered very good, and all of the modules, including PERC solar cell, hover around 20 to 21% efficiency. In fact, JA solar panels are so efficient that they are listed as one of the most efficient panels on the market. Okay, there is also JA Solar Company in Malaysia, which is located in Bayan Lepas, Penang. Okay, next is Jinko Solar, was founded in 2006 in China and it's headquartered in Shanghai, China. Jinko Solar is currently the world's biggest solar manufacturer, shipping the largest number of solar modules globally each year since 2016. The company does most of its global manufacturing in China, but it also has a factory in Penang, Malaysia, and one in the United States. The Solar Reviews expert panel has rated Jinko Solar the fourth best solar panel brand in 2021. The PERC solar cell offered by Jinko Solar is called the Eagle series. The average panel efficiency of Jinko solar panels currently available on the market is 19.82%. The most efficient solar panel available in the US right now is Jinko Solar Eagle G4, which has a maximum module efficiency of 21.16%. Okay, next, Haziq and Faris will explain further details about the fabrication process of PERC solar cell.
Okay, so I will continue with fabrication process of PERC solar cell. So as you can see here, I attached the difference between standard solar cell versus PERC silicon solar cell. Okay, next slide. So here is the process flow of PERC silicon solar cell at Trina Solar. At this time, which is around 2015, if I'm not mistaken, the efficiency is around 21.4%, but over the years, the efficiency keep increasing due to the modification of process flow of PERC solar cell in Trina Solar or other companies, which maybe add on something here and there in the process flow to make the efficiency of PERC silicon solar cell better. So I will go with the first four process flow, which is wafer surface texturization, PN junction formation, wafer side single polishing, and selective emitter formation. And the rest will go to Haziq. So next slide. So first and foremost, wafer surface texturization. So actually before this part, obviously the wafer need to undergo cleaning process. So after the pre-check, the front surface of silicon wafer is textured to reduce incoming light reflection losses. So the most popular technique to for monocrystalline silicon wafer is random pyramid texturing. So the pyramid texture is in place. With the pyramid texture, the incident light does not reflect back into the surrounding air and is lost, but instead bounces back onto the surface. So next slide. So for PN junction formation, so diffusion is basically the process of adding a dopant to the silicon wafer to make it more electrically conductive. There are basically two methods of diffusion, which is solid state diffusion and emitter diffusion. So while the former method basically involves the already mentioned uniform doping of the wafer with the P-type and N-type material, the emitter diffusion refers to the placing of a thin dopant material containing coating on the wafer bypassing the wafers through a diffusion coating furnace. So wafer that have been already pre-doped with a P-type boron during the casting process during the diffusion process given a negative N-type surface by diffusing them with a phosphorus source at a high temperature, creating the positive negative, which is PN junction. So next slide. So next is wafer single side polishing. So wafer single side process uses transportation roll on which the wafer lay. So there is no there's no upper transport system, and the wafer remains on the transportation rolls only by gravity. So the solution level below the wafer can be adjusted. The texture wafer have a hydrophobic surface, and therefore it is possible to etch them in a swimming process without requiring a wrap around. This is realized due to the meniscus between the acidic solution and the wafer surface on the lower side. So to avoid a modification to the emitter on the front, the polishing process must take place before the diffusion process. So after the diffusion, the silicon surface is hydrophilic, what leads to wrap around and attack of the front emitter. This is due to the acidic and chemical reaction gas phase for high silicon removals. So next slide. Okay, then is selective emitter formation. So selective emitter solar cells are characterized by localized region of heavy doping underneath the metal contacts. The effectively decoup effectively decouples the requirement of heavy diffusion in the vicinity of the contacts and the light diffusion in the light incident surfaces. So the heavily diffused region are limited to within the immediate vicinity of the contact, and the rest of the emitter is more likely diffused to enable good light absorption. So selective emitter can be fabricated in numerous ways, including laser doping, etch back processing, or by diffuse through a mask. In a laser doping process, a spin on dopant source is coating over the front dielectric, which is locally ablated with a laser. So over to you, Haziq.
Alright, can everyone hear me? Alright, then for wafer rear surface passivation, alright, so moving on from the upper and then the front and then to the rear surface, and we have a deposition of ALOX slash or silicon nitride, aluminum oxide or silicon nitride. Aluminum oxide or silicon nitride layer stacks are deposited using plasma-enhanced chemical vapor deposition, PECVD, with high deposition rates of several nanometer per second. Alright, regarding this, if you are confused about the difference with it between the statement and the diagram, as in the diagram I'm using aluminum trioxide and silicon nitride with an X. It is actually it's due to the development of what we surface the difference between the early vision and current vision. So actually they use silicon dioxide, and then it is not good enough. I'm simplifying a little bit. It is not good enough, and then they move on to silicon nitride, and then as dielectric, and then they also moving on to aluminum trioxide. I'm not finished yet. Back. Then finally, most of the current company have also developed this kind have started to use a mix of these two, aluminum trioxide and silicon nitride together to improve the dielectric properties, and also act as a passivation layer. Because passivation is a technology that prevent recombination between electron and holes on the surface of wafer. The next slide. Okay, wafer front surface anti-reflection coating deposition, ARC, deposition of silicon nitride. We still use silicon nitride because it is uh, a good ARC, and also it also acts as a passivation layer also. As a and it is deposited using PECVD. Then this there's nothing much I can comment on this because what I comment on this is PECVD is what is it? When we are using PECVD, we use lower temperature compared to using silicon dioxide. Then it to make it more simple, it will not the lower temperature will not break, will not disrupt the wafer. Yes, that's the simplification that I can give you. And then next slide. Laser ablation for real local. This part I need to make a quick disclaimer. This is purely my imagination. I'm sorry if I misinterpreted how laser ablation occur on the real local contact. So first of all, laser contact opening when uh, usually when you're trying to search a laser ablation in the internet, it always refer to LCO, laser contact opening. So they are basically the same thing. Then the real contacts are typically defined by laser ablation, LCO of the real precipitation forming line shape or dash line shape local real contact. Why you want to do this? It is for the next step process, but the video on laser ablation right here is made uh by a company. It shows how exactly laser ablation occurs. But to put it into perspective, to show you, uh, have you watched how people do tattoo removal using laser? Uh, that that is the way how laser ablation for real contact occur using LCO. Because in the television, we use photolithography and then we etch them and then we move on to LFC, laser firing contact, but all of them is uh, but LFC is used for aluminium that surface field only, but in PLC we want to make it aluminium local back surface field. So we use laser ablation because it it is most cost efficient way of making this uh whole line to for forming contact with aluminium. Alright, next slide. Okay, screen printing. It is a mainstream technology for front and rear side metallization. Grid contacts are applied on front side along with silver paste. For the rear side, most of the space is screen printed with aluminium paste. For the video right here is a video made by UNSW, the University of New South Wales. It is the university that first developed the PLC solar cell. So you can watch them here. So what exactly we are doing right now? After this, after screen printing, there will be co-firing. And then these two steps is actually two starting point. And after you have put a grid contact, something, have you ever seen how people make screen printing of t-shirt using hand by hand that push that they put paint and then they push the yeah, that kind of basically the kind of same thing, I think. That is the example that I can give you. But for silver, uh, the the upper part will form the bus bar and the uh, bus bar and fingers, and for the lower part, aluminium, they form the aluminium local back surface field. Alright, next slide. Okay, so this a picture of a front silver string with three bus bar. Yeah, that is bus bar. And then the horizontal line is what we call fingers on for a set. Alright, next slide. Co-firing. Co-firing of furnace firing you may found with this process with those two names usually. And in this process, the cell or wafer is fired in an inline infrared furnace where it experiences a peak firing temperature in the range of 750 to 870, or maybe sometimes I I once read it is in 850 degrees Celsius for 4 to 5 seconds, while the silicon locally alloys with the aluminium, forming a local silicon aluminium eutectic layer with the surrounding aluminium back surface field. You can see in the green colored, that is what we want in co-firing with the silicon aluminium eutectic layer. Eutectic means a mix of silicon and aluminium eutectic layer. That's all from me. Thank you.
Okay, thank you, Aziz. Now I will talk about our application of PERT silicon solar cell. As you know, PERT silicon solar cell has been used for factory, industry, and house because it are renewable energy. So the cell also can be used to power consumer products such as electronic door, car door, and watcher, and affordable radio. Also, calculator can be used. Also, calculator, solar cell has been used in calculators. Okay, but silicon solar cell also can be used in a remote area agriculture fair. So as you can see, the left side image, fail of water treatment pumping at China, he used solar cell. Also, it can use electric field because it don't cause pollution, so it don't affect our environment and global warming. So the next slide. Application solar of silicon solar cell use in building integration like other application in a new country like China. So the most it used in the fair of satellite because as you see, when the satellite at atmosphere, it cannot get energy. So how the scientists think want to use the energy because this silicon solar cell system usually have a long lifespan like between 10 to 50 years or more based on the issue. So it may be used in the field of electronic power generation generator as in Arab Saudi is uses. Arab Saudi is one of the largest country that use solar cell, panel solar cell for electricity on the city. And the last one in solar cell can be used for emergency power. So as you can see, the boy is have a power problem with a radiator thermistor and he use a solar cell. And that all for us. If you have any question, you can ask now.
Okay, thank you very much, group number 3. So now let's move on to our Q&A session. Any questions from the floor? You can unmute yourself. Anyone? No? Tak ada soalan. Okay, let me ask you questions. Right. For the PERC silicon solar cells, of the total solar cells produced in the market now, you showed the market share, right? What was it again? How much of the market share belongs to PERC silicon solar cells? As of now, 2020.
Yeah, 2020 is about 50%.
Okay. All right, so that's the first one. Any questions in between? No? A few more challenging questions. All right. Okay, maybe to Faris. Faris, what makes manufacturers move from back surface field, BSF, to PERC? Slide 11, right? Was it 10, slide number 10. Yes, why BSF to PERC? Haris?
To reduce the recombination.
Okay, so can you relate to the structure in the diagram? How does it reduce the recombination from left to right? Can you pinpoint the difference?
Wait, doctor.
What is the obvious difference between BSF on the left and PERC on the right? The standard one on the left is called BSF, back surface field technology. So that was the technology dominated the market in 5 years before, 5 years ago and before.
Maybe got the higher rear surface recombination and weaker electric field at the rear surface. For
the BSF or for the PERC?
For the BSF. That's why the.
So then when you move to PERC, what happens?
Oh yeah.
So the move must want to reduce the issues, right? Correct?
Yes, doctor.
All right. My next question is, do you know what is the typical thickness of emitter, the emitter layer on the PERC silicon solar cell? Can you go to the PN junction formation?
Sorry.
How thick is usually the junction? Anyone? Any ideas?
Can I get back later to you, doctor, for this thickness question?
Right. Okay. You add in the group. My next one is, anyone else with questions? You can just post or unmute yourself. I think the earlier part where I think I couldn't remember Shafika or Sakina presented about half cut. Was it Sakina?
The half cut.
Yeah, half cut
Yes,
cell, right?
Oh, okay.
Was it you, Shafika?
yeah.
Okay. Can you go to that slide? Half cut. I think the
Is that
earlier slides. Where is it?
Is this the one, Shavika?
No, the first part.
The first part. Okay. Oh. Okay.
Yeah, half cut, right. Can you elaborate a bit, Shafika, on this half cut? How does it look?
Actually, as we all know, usually the solar panels have one big side, like there's no what we call two part. Like it's only one part if we usually see on the top of the roof, right?
Okay.
So the half cut one, it's like it was part into half.
Okay.
First half and then the second half. That is the difference between the normal solar panel.
Okay. Any specific reason for the half cut?
It is to make the solar panels more efficient, so that if one of the part of the solar panels malfunction, the other one still can work. That is the reason of the half cut.
Okay. Well, just to extend the question, do you know how the cells are wired in the panels?
Oh, I haven't done a deep research on that, but I can post the link and website on the group later.
Okay, all right. Okay. My last question. How come you don't have questions from other groups? Group 1, 2, you can ask now. You're done, right? You finished your presentation. You can ask anything you like. Thickness of emitter is around 0.003 micron. That's 30 nano. Too thin, too thin. That's too thin, Faris. Try to. Okay, my last question while you're searching for the next one. 0.3, right? That's about 0.2, 0.3. Typically 200, 300 nanometer of emitter thickness. So if you're talking about P-type wafer and you are diffusing phosphorus, so your junction depth, so I want to relate back to the theory that you learned. The XJ, remember last time? The profile and the background doping, the XJ, the junction depth is typically around 200 to 300 nanometer for the PERC silicon solar cell. All right, my last question. I think Haziq presented about the rear passivation. So can you go to that slide and then can you explain a little bit how is the layer arranged in sequence? Is it like nitride first, then oxide, or oxide first, then nitride?
Wait trying
I think you label that one, yeah, 17, slide 17. Yeah, no, 16. I think you label on 16. Yes. So which one comes first?
on that part. Wait Usually aluminium. The commercial version is aluminium oxide on the top, and then the lower will be silicon nitride.
Any reason?
For that one, I'm not sure, but what I know is aluminum oxide is a negative charge dielectric, so I thought that must be related to it or something like that. Then
Why do you apply these two layers, by the way?
the main reason, so basically the aluminum oxide contains negative charge, which causes accumulation of holes and depletion of electrons at the rear surface, which assists with rear surface passivation. For silicon nitride, it is a tough dielectric that can withstand the firing step for the screen printed aluminium face. That's the reason why we are using both, I think, for the companies that together.
All right, okay. So any last question from the floor? Nope. All right, thank you very much, group number 3. Let's give them a round of applause. Virtually, you can. All right, thank you. So 10:40, let's move on to group number 4, solid state drive. Then we'll have a break for like 10 minutes and then we continue with cadmium telluride as the final one, yeah? Okay, welcome group number 4. You can turn on your video and share your slides. Okay, I can see half screen. Can you extend? I can only see half screen on the left. Can you go full screen? Yeah. All right, I can see full screen now. Good. Hold on. I can also see the pop-up window on the left. It has to be minimized. The square box on the slides. Okay, good. So, all right, so everyone's here, right? Okay, I can see Ahadia, Akida, Alia, and Ahadia, Akida, Alia, and Izati. Izati is wrong. Okay, Izati is here. Right then. Cool, right, you may start. 20 minutes and then we're gonna proceed with Q&A.
Assalamualaikum. Can you hear me?
Yes.
Yes. Okay. Assalamualaikum and good morning, everyone. So, our group 4, we will present the fabrication of SSD. So, next slide. So, these are our group members. Me, myself, Nur Akidah binti Maudai, will present the introduction of SSD. Next slide. So, next. So, SSD is a solid-state storage device that uses integrated circuit assemblies to store data persistently. Typically, flash memory. It is also functioning as a secondary storage in the hierarchy of computer storage. And it is also sometimes called a semiconductor storage device, a solid-state device, or a solid-state disk. So next slide. So why does it call a semiconductor storage device? Because there is no moving mechanical components in SSD. This makes them different from conventional electromechanical devices such as hard disk or floppy disk. So it is more resistant to physical shock. It runs silently, have quicker access time and lower latency compared to electromechanical devices. So SSD, the price of SSD has continued to decline over time, but SSD in 2018 are still more expensive per unit storage than HDDs and are expected to continue to be so in the next decade. So in 2017, most SSD use is 3D TLC NAND-based flash memory. So it is a type of non-volatile memory that retains data even when the power is lost. So next. So for me, the SSD is divided into two types. The first type is the more upgraded one, and the second type is more traditional one. So the first type, the PCIe and NVMe SSDs. So PCI Express is normally used to connect graphic cards, network cards, or other high-performance peripherals. So this interface gives you high bandwidth and low latency, making it ideal when you need blazing fast communication between SSD and your CPU. So this PCIe is based on the non-volatile memory express standard, which offers higher input-output per second and even lower latency than SATA. SATA is the traditional one. So NVMe boasts up to 16 gigabytes per second of raw throughput, which thanks to multiple parallel channels runs at up to 4,000 megabytes per second. So next. So this is the more traditional one, and SATA 3, and traditional SSDs. So Serial Advanced Technology Attachment SATA is an older interface that was designed specifically for storage with speeds up to 6 gigabytes per second or about 600 megabytes per second. SATA is slowly being phased out by NVMe, which is significantly faster. However, older PCs or laptops with a hard disk drive will still benefit from an upgrade to a SATA-based SSD. So that's all from me.
Start for the manufacturers of SS.
Hadi, can you be a bit louder? I can hear you, but not so clear. Oh, I think it's breaking. Can we turn on our turn off our videos for a while? Can we turn off our videos?
Oh, tak dengar.
Okay, it's okay. Hadi, you can turn off your video and then you can just present. Let me see if I can hear you clearer. Okay, all right.
Yeah.
Okay, can hear you.
Company
Right.
in technology project. Technology is marketed in China and good in memory products and technology solution. From SATA to NVMe, laptop to server, Kingston SSD provide the speed and reliability for upgrade that we need for PC book, servers, and system builder. They ship over 13.3 million SSD in the first half of 2019 and places the behind semiconductor manufacturers, Samsung and Western Digital. So next slide. The next is Intel Corporation. Intel is multinational corporation and technology company that provides technically advanced products that support every level of computing, and your SSD provide storage flexibility, stability, and efficiency. Other SSD brands will focus their attention on being able to present fastest and most powerful spec to their consumer, but Intel is more focused on the practical, and their SSD are well regarded throughout the industry for the reliability of their devices. Next slide. Next is Samsung Electronics. Samsung is one of the biggest players in the electronic gadget market and advanced in memory technology. Samsung are considered one of the most reliable SSD drive brands, and in 2021, Samsung introduced its first ZNS SSD and they introduced differentiated storage solution that can substantially enhance the reliability and the lifetimes of server SSD. Next slide. Next slide. You can move the next next generation ZNS drive enable higher thresholds for storage performance and capacity in the enterprise system. So now let's move on to the fabrication process.
Okay, now I'm going to explain about the fabrication process of SSD. There are four main processes to fabricate SSD, which is design, development, testing, and production. Next slide. So SSD is made up of silicon that is derived from quartzite, specifically sand, that has been purified and fused by nature. Once extracted, the quartz will undergo a process called Chokashki process. CZ. Quartz is melted and then crystallized by a seed crystal and drawn out in a long cylinder. This cylinder then will be sliced by a diamond saw to create a silicon wafer. Next slide. So SSD memory is created in dedicated factories that are referred to within the industry as fab. These fabs are clean rooms that are 100 times cleaner than a hospital operating room, as you know, to ensure that the silicon is not contaminated. Okay, once the silicon reach the fab, they are put through a numerous process of chemical bath and plating, just to prepare for the actual creation of the chip. The silicon wafers will go through several cleaning baths. The first bath is sulfuric acid and hydrogen peroxides, which is to clean the wafer. The second is the ionized water, ammonium hydroxide and hydrogen peroxide to remove particles from the wafer. Hydrochloric acid and the ionized water is then used to remove the oxide layer. This is a specifically vital step since the oxide will be used for the next part of the circuit. The final contamination removal bath is in the ionized water, the hydrochloric acid, and hydrogen peroxide. All these chemicals are generally sourced either as byproduct of other chemical reaction or synthesized. Next slide. So SSD manufacturers are reaching, as we know, are reaching the physical limits of how many transistors silicon can hold. This allowing for much more dense data storage. So whether it's stack or single layer chips, the creation of the circuit board will remain the same. So we use etching to design the circuit along with all the transistors. The step begin with a photoresist chemical is sprayed onto the wafer. And then UV light is shined through a template to cure certain parts of the photoresist to form the circuit pattern. And then the etching material is laid over the wafer, which will eat through in the places where the photoresist is cured. And then normally we use potassium hydroxide that will cause the silicon chips to form an oxide layer of silicon dioxide. And the silicon dioxide, we will call it as dielectric, which is a non-conductive layer that will have isolate layers of the circuit. The chip is then coated with more layers of etched conductive and dielectric silicon dioxide. And then this conductive layer can be in several different metals, but normally we use copper or aluminum. And then the chips are complete and are cut from the wafer. Next is Zati.
Okay, for the next part, after going through the development process, the SSD itself will undergo a testing process. In this testing process, the memory chip are individually tested to meet the advertised performance, and each of the SSD will undergo a series of tests that can last up to 60 hours, and then it will be further tested with a variety of motherboard to ensure the widespread of compatibility. In this testing process, the board will first go through an optical scan to verify that the components on the board are in a correct place, and then it will be X-ray on and then the board will be X-ray to ensure that everything on the board is soldered in a correct place, and then the large circuit board will be cut individually in size around 2.5-inch drive. And then for the next one is the SSD production process. In this SSD production process, this is the final element of the SSD fabrication process. In this process, as we all know, that SSD are built on printed circuit board, and the flash memory chips and the other component are mounted to the surface of the circuit board. And this circuit board is made up of a glass reinforced epoxy polymer plate printed with copper wiring. The non-flash chip are placed onto this board, and soldered in place with thin solder and gold wiring. The chips will be covered in a plastic casing to protect them. And then the whole assembly is placed into an aluminum case. The assembled circuit board are inspected and tested to verify functionality and quality. And then the finished circuit board are placed into the SSD case and then will be shipped. And then the SSD is ready to be shipped to the computer manufacturer or to a consumer. Do we have time? Do you guys want to watch this video? This video is how
How long? How long?
Huh?
How long is the video?
Around 4 minutes.
Okay, you can just play it. It's all right.
Okay. So next part, I pass to Akida for the application of the SSD.
So now we go to the application of SSD. So initially, solid-state drives SSD were designed for consumer devices. With the increased speed and power, various other sectors also came with a huge demand for them. So some are discussed below. So first, for the business tech sectors, companies depending on programming environments or data analysis often rely on SSDs, as access times and file transfer speeds are critical for them. So second one is gaming industries. For every gaming program, the computer requires a faster data access speed, enabling a faster load time, which is provided by SSD. So the third one is smartphones. With the continuous developments in smartphone industry, the need for small size, fast memory is best fulfilled by SSD. The fourth one is servers. SSDs can improve the server's response time due to its speed. They are suitable for faster read and write operations. And the last one is smart wearable and gadgets. The lesser space requirement, low power consumption, and high speed makes it an indispensable part of smart wearable and gadgets. So next is the conclusion. So why are SSDs important? So the first one is everything is faster. SSDs enable instant on, allowing your system to boot almost immediately. The second one is seamless multitasking. The improved data access of a SSD allows computer to run multiple programs with ease. Seamless multitasking gives you the opportunity to not only maximize your learning, but give you the ability to conquer more than one task on one screen. The third one is increased durability and reliability. Since SSDs have no moving parts, they are susceptible to damage, so they are extremely more durable and reliable. The fourth one is better system cooling. SSDs use flash memory, which means they are able to maintain more consistent operating temperatures, which will only keep overall system temperatures down, but it will also ensure your system stays alive for longer. So the longer your computers can stay alive, the less worries you will have stressing over buying a new computer and stressing over losing your files. And the last one is flexible storage. So SSDs are available in multiple forms. So some forms like mSATA are able to plug into your system motherboard, allowing the drive to work alongside your existing hard drive. Flexible storage is significant, especially for students, with the amount of assignments stored onto your computer will eventually slow down the efficiency of your computer. So this flexible storage allows you to organize your computer and to run it more efficiently. So that's all from us, Group 4. Thank you.
All right, thank you very much to group number 4. You can turn on your videos now. All right. Okay, so now let's move on to Q&A session. Any questions from other members?
Slide saya nak tengok balik slide siapa namanya Alia, boleh tak? Sebab saya
All right, Alia.
Yes. No, I mean before cleaning. Is this the only way of cleaning? I mean, isn't there any more ways of cleaning? And or should I say, yeah, I think.
This is the general one.
Oh, I see. Thank you.
Oh, just a short one. All right, so other questions? Anyone? All right, my questions. So do we have a manufacturer of SSD around us in Penang or in Malaysia? Which is? Yeah, anyone would like to answer that?
Micron.
If
Okay,
I'm not mistaken, Micron and also Lam Research, if I'm not mistaken. Lam Research is
Okay, Micron, yes, it is Micron in Batu Kawan.
Yes.
Okay, so if you look at Micron's LinkedIn, you can see a long list of vacancies. They're expanding now. And Lam Research is a company that manufactures equipments for wafer fab. So dia tolong buat equipment. You nak fabricate bukan, you nak manufacture thin film equipment. Dia yang buat. Dia buat the valve, the connection, the piping, the vacuum, the controllers as an equipment cell. So dia manufacturer, as one manufacturer for wafer fab. So there's a question here by Hadi. I want to ask how long for one SSD to be made? How long does it take? And does it take to fabricate? I think that is the process time. How long do you require? Yeah.
If I'm not mistaken, I've read somewhere. Keystone takes about 6 months at least to
Really?
complete the whole process. Yeah.
You mean from day one, from the silicon until the testing?
Yeah. Entire process.
6 months, that really long?
Yeah.
Okay. Okay, other questions? Okay, my next question is just a simple question. Is SSD a transistor? Alia, you have to unmute.
I think yes.
Okay, of any sort of transistor?
F apa MOSFET tau. MOSFET, something MOSFET.
So SSD is a device and is actually a bigger picture of another device.
SSD is apa sih?
Yes, Aizati? Is it a
Is
transistor?
is a transistor and SSD is made up of many components of transistor such as 3D NAND.
Okay.
3D NAND flash memory.
Okay, all right. So later on, I want you to share what is the structure of a typical SSD? How does it look like at transistor level? Is it looking like MOSFET or is it looking like a FinFET? Is it looking like some other forms of transistors? Okay. Do you guys have any ideas on how big is the dimension of the transistor in this case? So we've been learning about 22 nanometers, 7, 5, 3, 100. Any ideas of the typical dimension of the transistor used in SSD?
Maybe 7.
Sorry, 7.
Yes.
Oh, okay, 7, yeah. Because it has to be fast, right? You want it to be fast at switching, fast at booting and everything. So that means you need to use a very high-end type of transistors. Okay. All right. I think Alia mentioned about curing process. right? I know you mentioned about cure, right? You mentioned, yeah, somewhere, I think on this slide, yep. Oh, no, not on the previous one. On the red slide, the resist slide. So what was that curing process? Right, I'll come to your question, Faris, after this. Light is shined to cure certain part of the resist. What is this curing process?
Lithography process, if I'm not mistaken.
Yeah, but technically what curing is? Well, it is lithography to define regions. But then when you cure, in this case, curing is quite broad. Even when you talk about fabrication processes, some cases use cure to show a hardening process.
This part is
it the hardening as well? Cure
yeah,
certain
because
part
it
of the
want to
resist.
make the part become the circuit.
So that's not going to be removed then, right?
Yeah.
Okay. All right then. Okay, last question. From Faris here, is it possible for 3 nanometer SSD to be made? This is a future question.
I think yes, and
Mhm.
if I'm not mistaken, some
Wait,
there are
some
some company that are doing the R&D right now and are figuring out how to make this thing smaller but much more become efficient.
Okay.
Samsung, if I'm not mistaken,
Mhm.
Samsung
All right.
is doing the research on this 3 nanometer SSD.
Okay then. So that means it's coming because it's now in R&D, so it's coming in mass production pretty soon. Right. So thank you very much to group number 4. Jangan sikit virtually. Dalam kelas ni saya suruh semua tepuk tangan kuat-kuat. Kau dalam yang kuliah lah. Right, thank you very much. So let's now 11:15. So we'll have a break for about 10 minutes. Okay. So we'll come back at 11:25. So for the final presentation by group number 5 on cadmium telluride solar cell. Right. So I'll see you back. I'll see you again at 11:25. Okay, then bye for now. Okay, welcome back. Group 5 is ready. And turn on your videos. Okay, you can go full screen. You can turn on your videos as well. Mimi, Shasha, Izati, Noroda, and Sari Iziani. So everyone's here, right? Okay, if you're ready, then we can start your presentation. So it's up to 20 minutes, and then we'll proceed with Q&A session as usual. All right, over to you guys.
Good morning to everyone. We are from Group 5, are going to present on the fabrication cadmium telluride solar cells. I am Nur Shasha Izzati binti Muhammad Khalid. Next slide. Next slide. What is solar cell? Solar cell or photovoltaic cell is a device that directly converts the energy of light into electrical energy. Next slide. Next. What is cadmium telluride solar cell? Cadmium telluride solar cell, also called cadmium telluride photovoltaic or cadmium telluride thin film, a photovoltaic device that produces electricity from light by using a thin film of cadmium telluride. It differs from crystalline silicon photovoltaic technologies as it uses a smaller amount of semiconductor thin film to convert absorbed light energy into electrons. The second most common photovoltaic, The second most common photovoltaic technology in the world marketplace after crystalline silicon. It is currently representing 5% of the world market. It can be manufactured quickly, providing an alternative to conventional silicon-based technologies, cheap to produce, and the technology has the potential to surpass silicon in terms of cost per kilowatt of installed capacity. High optical absorption coefficient and high chemical stability also appear in cadmium telluride. Cadmium telluride is a very robust and highly chemically stable. It can be deposited with a large variety of methods available, making it very much ideal for production in large area. Materials used are cadmium, tellurium, and cadmium chloride. Next. About cadmium telluride solar cells. Cadmium telluride solar cell thin film photovoltaic technology was introduced in the early 70s of the last century. It is now the only thin film technology in the first top 10 producers in the world. Cadmium telluride solar cells were introduced for the first time in 1972 by Bonnet and Rebbenhof. Next. How researchers has achieved high efficiency for cadmium telluride solar cells. Cadmium telluride has an optimum band gap near 1.5 electron volt according to the Shockley-Queisser limit so that it could deliver efficiencies around 32% with an open circuit of more than 1 volt and a short circuit current density of more than 30 milliampere per centimeter squared. It matches the solar spectrum very well. A series of improving steps introduced, among them high substrate temperature during cadmium telluride deposition, cadmium chloride activation treatment, copper doping, brought to high conversion factors above 15%, followed by the 16.5% record which was obtained at the National Renewable Energy Laboratories. The strong improvement in efficiency in the last 5 years was obtained by a new redesign of the cadmium telluride solar cell device, removing cadmium sulfide and considering new features such as band gap grading, copper embedding, and more transparent end layer. With these changes, First Solar have delivered a 21.5% efficiency device, later improved to 22.1%. These results have been gained from materials obtained from the production line. This demonstrates the high potential in terms of scalability of this technology. In fact, a large area module of 19% was measured for 23,573 centimeters squared cadmium telluride thin film fabricated by First Solar and measured by Fraunhofer Institute for Solar Energy System (ISE). Next. Manufacturer of cadmium telluride solar cell in Malaysia is First Solar. First Solar located in Kulim, Kedah. Here are the details found on web regarding First Solar. In early 2017, First Solar said that the Tetra Sun production plant in Malaysia would be converted and dedicated to its cadmium telluride thin film series 5 module assembly requirements and be operational. Next. In this part, I'll be stating the most common manufacturers. First of all is the one that I mentioned in previous slide, which is First Solar. It is also located in the US along with DM Solar and Real Solar Power. Next, manufacturers located in Germany are Calixo and CTF Solar, Advanced Solar Power and CNBM Optoelectronic Materials located in China. Lastly, SunQ in Morocco. Thank you. Next, we'll have Nurul Huda to present on fabrication process cadmium telluride solar cell.
Thank you. Okay, fabrication process cadmium telluride solar cell. Okay, the first stage is substrate cleaning, which is a robotic loader connected with a washing machine, just like a diagram, and iron-free SLG, which is soda lime glass, washed by means pressurized deionized water jet, and then it dry in a filter hot air stream. Okay, next is first heating tunnel. The soda lime glass substrate move on a rail in a vertical or horizontal, and then the heating tunnel evacuate chamber is at 10 MBAR. It is heat up to the deposition temperature of the TCO layer, which is transparent conductive oxide layer. Okay, next, the heating must be very uniform because it is to avoid thermal shocks, and it could cause glass break. Okay, the heating tunnel is equipped with infrared IR lamps, and a PID system controls the power supply through the temperature feedback. Next. Okay. Next is the sputtering TCO. Okay. The deposition takes place at 400 Celsius to guarantee the correct stability of stacked film, and the targets in a vertical position are of the cylindrical rotating type to efficiently use up to 95% of the starting material. ITO and zinc oxide targets are deposited by means of a DC and RS sputtering power supply respectively. Okay, after that is first cooling tunnel. Okay, since the next is the first laser scribing, temperature is to decrease up to 25 degrees Celsius. Okay, it substrate covered with the front contact comes out from the sputtering chamber and enter the cooling tunnel. Okay, the cooling rate is very similar to the heating one. Okay, first laser scribing. It is to eliminate the TCO along parallel lines at a distance of 1 centimeter from each other. 40 per 60 micrometer wide is typically used. And it Q-switch and S regime diode pump solid state laser DPSSL, working at wavelength of third harmonic depending on the IR and UV cutting respectively. Okay, the next is the second heating tunnel. Before the deposition of the window layer, the temperature of the TCO covered with soda lime glass must reach 200 degrees Celsius. Okay, this heating tunnel is 7 meter long, is equipped as the previous one. Next. Okay, next stage is sputtering of CDS layer. Tak nampak dah pula. Tak boleh zoom slide ni, tak nampak dah tulisan. Okay, thank you. Okay, sputtering of CDS layer, a planar RS sputtering equipped with at least 3 CDS ceramic targets, which will provide the deposition of the window layer. And then, bawah sikit. supplied by a RF power density of 3.5 watt per cm square, and it alternative to the sputtering technique, which is chemical bus deposition CBD, could be implanted for the deposition of the CDS layer. Since CBD is carried out at a very low temperature, the proceeding heating tunnel is not necessary. The deposition occurs inside thermostatic baths containing the saturated solution. Okay. Next is the third heating tunnel. It is deposition of the cadmium telluride film by CSS or CSVT, require a temperature of about 500 degrees Celsius. The soda lime glass covered with a TCO and CDS layer runs into a heating tunnel while the temperature varies from 200 to 1500 degrees Celsius. Doctor, I have a emergency family. I need to go to hospital. Can I
okay.
leave?
Yeah, it's okay, it's all right. You're done, right?
Yes. Sorry, doctor.
No problem. Hope
Sorry.
everything is okay.
Okay. Sorry to my group too. And if anybody have question about my part, can ask in the WhatsApp. I will reply later.
Okay, all right.
Thank you, doctor.
No problem. Take care.
Okay.
Okay, so I will continue with the fabrication of the cadmium telluride solar cell. After the cadmium sulfide have been deposited, the next step is deposition of cadmium telluride by using closed space vapor transport. Closed space vapor transport is a physical technique where it takes place in vacuum chamber. They were heated to 500 degrees Celsius through electrical resistance. This technique allows a very high deposition rate, which enables the deposition of relatively thick cadmium telluride film within the production cycle time. The deposition process begins as the heat causes sublimation of cadmium telluride and the vapor deposited onto the surface of the cell. Then the sample undergoes second cooling tunnel, where it lowers the temperature from 500 degrees Celsius to the typical temperature of the chlorine treatment, which is in the range of 360 to 400 degrees Celsius, since the next step is chlorine treatment. Chlorine treatment is essential for the production of functional cadmium telluride solar cell. The treatment is carried out at a temperature of about 400 degrees Celsius in a presence of cadmium chloride and oxygen. The chlorine can be supplied by dipping the cadmium sulfide cadmium telluride system into tank containing the cadmium chloride methanol solution as shown in the figure, or by simple sublimation of the cadmium chloride. This treatment reduces the cadmium telluride at standard defect density and also increase the p-type conductivity. After that, the sample undergo the third cooling tunnel, where the temperature is further lowered from 400 degrees Celsius to the room temperature before entering the washing machine. In the washing machine, any cadmium chloride residue or oxide formed during the chlorine treatment are removed. Then, second laser scribing takes place. This patterning step selectively removes the active layer close to one edge of each cell delineated by the first scribing.
The laser action only has to remove the cadmium sulfide and cadmium telluride semiconductor, leaving the unchanged, completely clean surface of the underneath TCO as shown in the figure. Before the deposition of metallic film, buffer layer are added between the cadmium telluride surface and the metallic film to achieve an ohmic contact. For the metallic film, it consists of copper or molybdenum or nickel vanadium film. This deposition is normally carried out at room temperature, and then both buffer layer and metal contact are deposited by using a direct current sputtering technique. The sputtering chamber is equipped with a sufficient number of cylindrical rotating targets to perform the film deposition in the requested cycle time. Then the third layer scribing takes place where this scribing removes the back contact and the active stack film close to the second scribing, keeping the underneath TCO layer as unchanged as possible. In this way, every cell is series connected with its adjacent, as shown in the figure. The production line ends with the installation of bus bar and a junction box with the external cables. And lastly is the lamination operation, where a thin ethylene vinyl acetate sheet placed between two glasses. The finished PV module is subjected to the so-called flash test to learn the electrical output power and the characteristic photovoltaic parameters. The test results are printed on an adhesive label, which is automatically attached to the back of the panel. The test modules are automatically divided into output power classes and packaged in order to be shipped to their final destination. Here is the summary of a fully automated inline process for the fabrication inline fabrication for the production of cadmium telluride, cadmium sulfide based PV models. That's all from me. I will pass to Suri for the next part.
Hi, I'm Sri Isyani. I will explain about application of cadmium telluride. Next. There are several largest solar power stations in the world, such as Desert Sunlight Solar Farm, Topaz Solar Farm, and Ningen Solar Plant. Next. The Desert Solar Farm is a 150 megawatt photovoltaic power station. It is located approximately 6 miles north of Desert Center, California, United States, in a Mojave Desert. The sun shines at least 300 days of the year, bathing more than 8 million photovoltaic panels at the Desert Sunlight Solar Farm. All that free sunlight is converted into electricity that flow into California's thirsty power grid, eventually helping to charge iPhone in Los Angeles and switch on TVs in Sacramento. In the past, panels were often made using silicon, which tended to yield more energy, but were expensive and difficult to mass produce. But First Solar has shied away from silicon and instead produced thin film panel made with cadmium telluride, which can be cheaper than silicon but less efficient in converting sunlight into energy. It uses approximately 8.8 million cadmium telluride modules made by United States thin film manufacturer First Solar. Next. The next solar power station is Topaz Solar Farm.
A fast solar farm is 550 megawatt photovoltaic solar power project. It is one of the world's solar farm. It includes 9 million cadmium telluride photovoltaic modules based on thin film technology that will produce sufficient electricity to power approximately 160,000 average California homes. This solar farm generates electricity with no emission, with no waste product, and no water usage. Next. Ningen Solar Plant is one of the largest operating solar plants in Australia. Ningen receives strong and consistent solar radiation, making it an ideal location for a solar power plant. About 1.35 million solar photovoltaic modules were installed, generating 102 megawatts power, supported by 150,000 steel posts. This module were fixed at 25 degrees facing north. They are wired together in array and connected to inverter, which transform the DC current produced by the modules into AC current that feed into the grid. These 1.36 million modules will have higher energy yield than traditional crystalline silicon that will also produce no carbon emission and will require no water during operation. Next. This slide will explain about advantage and disadvantage of cadmium telluride solar cell. The first one is it is low cost manufacturing. Cadmium telluride solar cell use high throughput manufacturing method to produce complete module from input material in a matter of hours. It also has high absorption. Cadmium telluride is a direct bandgap material with bandgap energy that can be tuned from 1.4 to 1.5 electron volt, which is nearly optimal for converting sunlight into electricity using a single junction. Cadmium telluride is also abundant and environmentally friendly. It produces little part of carbon footprint and has the lowest water usage, even has the shortest energy payback time, approximately less than 1 year. However, this material still have a disadvantage. The first one is tellurium is an extremely rare element. The availability of tellurium will eventually limit the number of panels that can be produced with these materials. Cadmium telluride is also toxic if ingested. It must also be handled properly with appropriate gloves and other safety precautions. That's all from our group. Thank you.
All right, thank you very much to group number 5. So, right, so let's move on to our Q&A session. Okay, any questions from anyone? All right, anyone with questions? No? Okay, my questions then. Do you know the thicknesses of TCO and cadmium telluride in this case? The thicknesses of TCO and cadmium telluride. How thick are they?
For the cadmium telluride, the thickness is about 4 to 8 micrometer, while TCO is I'm not sure with the TCO layer.
Okay, anyone like to add on that with TCO thickness? So let me just go to the second question while waiting for the TCO thickness. So in these cadmium telluride solar cells, all right, okay, TCO is around 500 nanometer by Shasha, right? Okay, it's about 500 or less, okay, 500 nanometer or less. So in this type of solar cells or solar panels, which layer is the layer that is responsible for the electricity generation? Which layer does the conversion of the PV conversion?
I think the cadmium sulfide and cadmium telluride because it's the active layer.
Okay. Which one is P and N? If you know, P type
N
and type.
is N is cadmium sulfide and the P type is cadmium telluride.
Right. So they both form the PN junction. Okay. So if you look at the thickness of cadmium telluride, so that's about 5 micron or so, and cadmium sulfide is typically in the range of 300, 200, 300 nanometer. So those two form the PN junction for the light conversion. Okay. And the rest is just TCO is the front contact, and then you have your rear metal contacts, buffer and stuff. Right, any other questions from others? Ada soalan semua dah nak habis kelas lah. All right, so I have 2 more questions, all right? Bear with me. So you have shown the slide with a couple of steps on laser scribing.
Yes.
Right, can you elaborate a little bit why laser scribing?
Right. Yes.
Or what is laser scribing before that? What is actually happening there? Can you go to the slide where you showed laser scribing? Maybe it's easier to explain.
This one?
Oh, okay, this one then. Yeah, sorry. Okay, so why scribing? Or what is scribing? What do you expect to happen here? When you scribe, so what do you get?
I think it's like the photoresist to make a one of photography.
So it's pretty much like litho and etch effect, right?
Yes.
Because you dig hole, basically you dig the openings, right? And in this case we use laser scribing, and we didn't learn laser scribing, but if you see this slide, then you can relate right away to litho plus etch kind of effect, because you want to open certain areas for you to do certain things. Okay, so yeah, it's a bit unique when you see the scribing for TCO, and then you see the scribing for cadmium telluride. So you wanna do a few unique things. Okay, my last one, bear me. Heating tunnels. What is that? Heating tunnels. What do you actually do? Can you go to the summary of the flow? I summarize the whole processes in one this one. So I can see 3 heating tunnel steps. So can you elaborate a little bit these heating tunnels? Anyone?
It's like annealing to
Okay.
remove residue or oxide on the surface to make it less defect and more conductivity.
Okay, so the effect is pretty much like annealing, but if you look at the 3 different steps there, 3 different heating tunnel steps, so they are actually unique depending on the step. If you look at this, the first one is after the washing machine. So that must want to dry the samples or dry the glass before TCO deposition, right? because you don't have defects just yet, because there's no layers to begin with, because it's just glass before TCO deposition, isn't it?
Yes.
Then you have the second one after the first scribing, and then the third one after the cadmium sulfide. All right. All right. Any last question from the floor? Almost done. 11:55. Ada last question? Any burning question to group number 5? Any burning? No. No burning. No burning questions. Ada. Right. Thank you very much, group number 5. A lot of applause to them.
Thank you, Dr.
All right. Okay. So we're done. Habis. Alhamdulillah, selesai. All right. Hold on, yeah. So we have completed our group presentations. Congratulations to all of you. Okay. Tahniah kepada semua. You've prepared quite well for all the groups. From FinFETs, gallium nitride LEDs, PERC silicon solar cell, SSD, cadmium telluride solar cell. Well, if you look at the, okay, turn on your videos. Can we just chat for a while and we snap some pictures before we finish off? Cool, long time no see. Lama tak jumpa. Right, turn on. Sambil-sambil saya sembang-sembang ni. So yeah, group presentations is meant for us to cover other stuff that we have not covered during the core of the course. So as I said earlier on, when we learn about fabrication processes in this course, sorry ya punya recorder kat belakang anak saya tengah practice. Bukan practice lah, randomly tengok recorder kat belakang. So yeah, okay, so we've only managed to cover CMOS largely. Sekejap. Hold on, bear with me. Okay, sorry ya. Selingan sekejap. Okay, so this course is meant for CMOS fabrication, but as I said earlier on, the processes that we've covered for CMOS fabrication can also be adapted to other devices. Okay, so you can relate right away when you talk about FinFET, for example, and then gallium nitride LEDs, silicon solar cell, SSDs, cadmium telluride. So you can see litho, you can see etch, walaupun ada certain part that are not so obvious. Tapi you can still relate, right? Boleh nampak kan? So when we talk about other devices and you have also presented about the manufacturers, you can tell already litho kat mana, etch kat mana, diffusion, junction depth, thin film deposition, we can see a couple of times coming up. So these are the things that you have learned in this course. Okay, so the basic processes are the same, but you just have to adapt to different semiconductor devices. And obviously kita tak sempat nak cover all the semiconductor devices punya process flow because it's just too many and too unique for respective device. Okay, tapi as long as you understand the basic processes, you can just pick and adapt accordingly. Oxidation ke whatever process yang required. And you can also notice that not all processes are used in all devices, but at least a couple are used in some devices. Okay. So I hope you learn a lot from the presentation sessions and also from the course. Okay. All right. So we have finished everything. Okay, we're gonna have our test 2 normal classes finish. We're gonna have our test 2 next Friday, open book, So in between it's just your study time and it's a revision week anyway. So we're gonna have our open book test covering from etching till the end of the course. Okay, sampai integration and metal interconnects and stuff. And then I'll post your presentation videos on YouTube through eLearn. And then nanti group leader tolong emailkan. I've seen one from Sakina just now. Please email to me your PDF slides so that I can share on eLearn and you can get benefits from it. It's going to be very useful later on when you go for your interview and for your job hunting. How do I know? Sebab student yang dah grad 1 year, 2 years, yang dah tak simpan notes, I know you don't keep. Perhaps some of you keep the notes. Ada yang dah grad 2 tahun, contact saya minta lecture notes. Lecture notes untuk next interview or whatever. Okay, by the way, you should keep the notes first, right? Don't just ditch away. Don't just ditch the notes because it's not just for exam, it's also useful for your future career as well. Okay. All right, so that's it. So if I may know, how's your internship application progress? Is it progressing well?
No.
No, ada company yang memang tak open langsung ke? Ada kot yang memang tak ambil langsung, I think. But some have secured positions, right? Right? Am I correct? Ada yang angguk tu, angguk pun slow-slow je. Well, I hope most of you, all of you have secured. Tapi ada juga yang memang plan not to take internship. That's all right. So you can go for your internship if you know where you want to go and your future path. Walaupun mungkin ramai yang masih belum clear. But you can also stay and take courses if you want to repair your CGPA. That's equally fine. Okay, it's not like you tak pergi tu memang something wrong with you, no. Because it's not compulsory to begin with, but we highly encourage students to go, especially if you want to land your first job in industry and you know where to go, right? So, but it's not wrong not to not go because you can always stay and take courses and improve your CGPAs and stuff, right? Okay. So I guess that's all. Okay, kita ambil satu gambar, then we're done. 12:03. So let me just see if everyone can fit into this. 1, 2, 3, 4, 5. 20 cukup je. Tak ada second screen lah. There's no second screen, right? There's no button for me to press to the right. Semua 20 participant. 1, 2, 3, 4, 5. Yep, all 20 in one screen. Okay, give me your best pose. Nanti saya share langsung. All right, let me just, you can capture as well. Let me just print screen from my side. Yeah. Okay, senyum. 1, 2, 3. Okay, hold on. Let me just capture the screen. Okay, one's done. Right, the second one, freestyle. Yeah, freestyle. Let me just confirm the first one first. Looks good. All right, freestyle. Okay, freestyle. Saya kena pakai dua-dua jari, so dua-dua tangan. So I cannot go free. Okay, you all freestyle, huh? Okay, 1, 2, 3. All right, so that's done. Thank you very much for being with me, for bearing with me for the past 15 weeks, right? Okay, thank you very much. And kita tak dapat nak buat lah due to COVID. We didn't manage to do the fabrication. It's supposed to be 3 weeks before your presentation. Tapi we switched to this kind of presentation just to get things going. But I think you learn a lot as well during the preparation of materials. You can actually nanti, well, if you want to apply for internship and job, you can also use this kind of group presentation as your something like sub presentation or something in your CV. Boleh, you can just put that. It's a matter of how you explain things. right? It's not like bila you present and there's no fabrication work, is useless. No, you can always put it there, but as long as you know how to explain how does it matter to the potential employers, then you can always make a good point out of it, right? So just be creative around this internship application and your future as well. So I wish you all the best for your next semester, whether you're doing internship or you're taking courses. So hopefully we can see each other face to face again. We don't know when. Tapi USM seems to be allowing 50% of students coming back, although it's not yet finalized next semester. So kalau you dibenarkan pun, perhaps yang ambil course lah yang akan balik kan, yang lain mungkin dah out for your internship. So all the best for your internship application and also your courses. Take care and stay safe. So saya nak minta maaf kalau ada any hiccups from my side, any problems, any issues, any weaknesses that I could not deliver during the course. So saya pun insan biasa juga, but I think I've tried my best to deliver the content and to teach you whatever I can. We can always discuss in the group later on. Kalau you ada apa-apa persoalan on internship that you're not clear, ataupun you cannot decide, you know, kadang-kadang student tak nampak nak sini ke sini, ataupun ada mungkin some of you can relate to this, you dapat few internship application nak ambil yang ni ke yang ni ya. So how do you weigh the, you know, before you make decisions, right? So and you will always get this in the future as well. Kadang-kadang you dapat your first job, your second job, your third job from a couple of companies, and you need to weigh with the salary. Kadang-kadang salary okay, this is the thing that you will face sooner or later. Gaji tinggi tapi tempat jauh. Rumah apa ni, you punya tempat kerja dekat, gaji sikit, gaji rendah pula. Gaji tinggi, tempat dekat, kawan tak best. Bos pula tak best. Gaji tak apa ni, kawan best, boss okay, you know, nature of the job okay, then that's life, right? This is what you have to weigh eventually. There's no such thing as a perfect job for everyone. Okay, kalau you dapat tu mungkin it's too ideal to be imagined, but there are cases like that, but it's very hard. It's always like a juggle of, you know, gaji, tempat, kawan, boss. You'll come to this. Okay, you'll come to this later on. Then I know that you'll make decisions based on these couple of factors sooner or later. Right, so I guess that's all for today and for this semester. So I'll see you again virtually on your test 2 day. Sebelah hari bulan 2. So I'll just upload the test question as usual. You have 2 hours open book and prepare for it properly. Yeah, so you have times before the test for your preparation. So that's it. Bye-bye. Take care. Stay safe. Assalamualaikum.
Thank you, Doctor.
All right.
Thank you,
Thank
Doctor.
you, Doctor.
Yeah, no problem. See ya.
Thank you,
Take care.
Doctor.
No worries.